In this video, I'm going to be showing you how to solve horizontal projectile problems. With a horizontal projectile, the object starts out at a high spot, goes horizontally off that, and is carried downward. Let's look at the problem. A skateboarder rides horizontally off a 2-meter high wall and lands 2.8 meters away from the base of the wall. What was his initial velocity? The first thing we do with a horizontal projectile problem is draw the horizontal diagram. There's the diagram. Pretty good, huh? The way this works is that the object starts at the top and it goes with a horizontal velocity, Vx. Vx is the same as the initial velocity for these problems. The object is going to go down, 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 and it's going to land some horizontal distance away from the base of the high object, in this case the base of the wall. That horizontal displacement is delta x. The height that it falls from gives us our vertical displacement, delta y. Remember though, because the object is falling downwards, delta y is going to be negative. It starts out from a higher position and goes to a lower position. So you take the height, and the negative of that is our displacement. Finally, like with all projectile problems, our acceleration is negative 9.81 meters per second squared. And because the object starts out going horizontally, it's not going up or down, our initial vertical velocity is 0. This part here is true for every single horizontal projectile problem that you'll see. All you have to do is plug in the specific information. Here, our wall is 2 meters high. So that's my delta y. But remember, I have to make it negative 2 meters. In these problems, they'll either give you the Vx or the delta x. They'll either give you the speed it was going when it left, or they'll give you the displacement when it landed. In this case, they tell us that it lands 2.8 meters away, so that is our delta x. And they're going to ask us to find the Vx, which again, for a horizontal projectile, is equal to the initial velocity. So my delta x is 2.8 meters. In order to find the initial velocity, or the horizontal velocity, I need to use the horizontal equation. The horizontal displacement equals the horizontal velocity times the time. Delta x equals Vx delta t. I'm looking for Vx here. I know delta x, but I don't know delta t. So I have to use my kinematic equations to find that. I know delta y, a, Vyi, and I'm looking for delta t. Once I find the time, I'll be able to plug that into the horizontal equation. These are 4 of our 5 variables. The only one that's missing is Vyf. So I need to use the equation that does not have Vyf in it. When I look up the equations, I see that delta y equals Vyi delta t plus 1/2 a delta t squared is my kinematic equation without Vyf. Now I just need to plug in my numbers. Negative 2 equals 0 times delta t plus 1/2 times negative 9.81 delta t squared. 0 times delta t is just 0, so I can get rid of this one. Negative 2 equals 1/2 times negative 9.81 negative 4.905 delta t squared. Divide both sides by negative 4.905. And we get
negative 2 divided by negative 4.905 equals
0.408 for delta t squared. Now I need to take the square root of both sides. And I get a delta t of 0.639 seconds. So there's my time, but I'm not done yet. Remember, I'm looking for the initial horizontal velocity. So I can now plug my time into this equation and solve for that. My delta x was given as 2.8 meters. I'm looking for Vx, and I know my time is 0.639 seconds. Divide both sides by 0.639. I get 4.38 meters per second for Vx. That's pretty much it. Just about every horizontal projectile problem you see will follow this same pattern. You use your height to find the time that it takes to fall that distance, and then you use either delta x to find Vx, or if they give you Vx, you'll use that to find delta x. Another thing they may ask you with horizontal projectile problems is, what is the total final velocity? In the last problem, we found that the time was 0.639 seconds for this object to fall 2 meters. We're going to use that to find our final vertical velocity, and then we'll add that to our horizontal velocity to find the total velocity. I can use this equation to find my final velocity. Remember, Vyi is 0, my acceleration is negative 9.81, and we found out that the time was 0.639 seconds. So some quick calculating. Gives me a VYF of negative 6.79 meters per second. This negative sign for VYF, all that means is that the object is going down. So now I want to add this final vertical velocity with my horizontal velocity, which hasn't changed. I have a horizontal velocity of 4.38 meters per second. We found that in the last problem. I have a vertical velocity of 6.79 meters per second downward. What I want to do is I want to find the resultant when I add these two vectors tip to tail. The resultant vector will be the hypotenuse of this triangle. Final velocity. If I know two sides of a right triangle and I'm looking for the third side, I need to use the Pythagorean theorem. It doesn't matter which leg you use for A and B, but the diagonal is always going to be C. Some more quick calculating.
Okay, c squared is 65.3 meters per second, meters squared per second squared.
I need to take the square root of both sides now. I get a total velocity of 8.08 meters per second. So that's how fast it's moving at the end. The vector, though, has two different parts. How fast it's moving, the size of the resultant, but also we need to know the direction that it's going. So I need to find this angle theta. For that, I'm going to use the inverse tangent. When you're looking for the angle, you use the inverse trig functions. This is the opposite side from the angle, and this side is adjacent to the angle. So my inverse tangent of 6.79 over 4.38 is going to give me my angle. Quick calculate. $57.2 degrees. So my final velocity is 8.08 meters per second at an angle of 57.2 degrees below horizontal, this way. That's all.